Okay, it says to graph the following. Let's go ahead and graph the easier one. I think x equals 2 will be an easier one. What kind of line would x equals 2 give us? Horizontal or vertical? If y'all remember Hoy and Bugs from last year, vertical lines are x equals, and then y would be horizontal lines are y is equal to. Just as a reminder. So let's go ahead and graph these. I have a vertical line through x equals 2. You can freehand draw because notice the grid already has a line for us, right?
Whoa.
Yep. Just not the diagonals. And then we have a horizontal line through x equals -1 or y equals -1. And again, you can go along with the line that's already provided. And then we have 1/2 x plus 3. So going back to algebra 1, we start with the y-intercept. Let's all put a dot. And then we use our slope, up 1 over 1, up 1 over 1. And I can go in the opposite direction. And if you think you have enough, you can freehand draw or use a straight edge. I'm going to use my beautiful ruler. Boom. So there's a specific feature about this one. Just by looking at this, do I have a right triangle? Yep. Does that mean every triangle I make has to be a right triangle? No. So let's go ahead and notate the right angle just to be specific. All right. So today we're looking at triangle midsegment. What that basically means, it's not the median, because median is a point on a segment, but midsegment actually goes from midpoint to another midpoint. So it's 2 midpoints. So let's go ahead and put on here, pinpoint the middle of, we should call this a name, A, B, and C. So let's go ahead and approximate the midpoint of AB, and let's call that D. And let's approximate the midpoint of CB, and I believe it's going to be somewhere right over here. Is that right? Since I have a grid unit, 5 units and 5 units, let's go ahead and call that E. And then our last one, call this one F. And let's make our consistent tick marks. 1 on here, 2 down here, and 3 on my diagonal. And then what I want you to do at this point is connect that smaller triangle DEF. And yes, you can use your straight edge. And where does the right angle fall this time?
On the opposite side.
On the opposite side, or specifically on angle DFE. So I want to talk about something that is unique about all of these. Let's start by highlighting the big triangle with one color. You don't have to highlight, but if it helps, please do. And smaller one with the other, although I can kind of leave it as it is. And something unique is happening here. How many congruent little triangles do I have? 4. Yeah? So then if I kind of think about it, we know AD is congruent to DB, so is FE congruent to them as well. So then I know CE is congruent to EB, and so is who? FD. And then I have CF is congruent to FA, and so is ED. So here's the bottom line. The parallel parts have 3 sets of congruent segments. This parallel part has 3 sets that are congruent. And then this parallel, we have 3 sets that are identical. So here's our summary on this. I just explained it, but I want you to write out the following. So we know FE, FD, and ED are called the midsegments. And we'll reiterate the vocabulary on the bottom pretty soon. And it creates 3 sets of parallel lines. And we have 2 unique features about the perimeter and the area. So write them down. Let me make sure it's recording. Perfect. So let's look at the perimeter then. Is the perimeter on my tiny triangle really half of the perimeter on the outside? Yep. Is the area of the tiny one a fourth of the whole thing? A quarter of the whole thing? Yes, it is. All right. So I want you guys to go to the very bottom, and I want to mention something that's going to be important on your assessment. So on the very bottom, let's talk about all the features of something that has to do with the middle. So yes, do go over this on your own. Let's start by making a segment. And then I want you to make two scalene triangles to the left of it, because I don't want to assume starting with the scalene is always good. Yeah, if your figure turns out to look like an isosceles, what can we say about that? The figure is not drawn to scale. All right. So at this point, the first thing that I taught you back in Unit 1 was the midpoint. This right here is a midpoint. And midpoint is a dot at the center of a segment. And then what we talked about yesterday when we built a centroid was from the vertex to the opposite that is congruent. This right here is called the median. And it's median on this one specifically because it went from the vertex to the midpoint. So they're not all the same things. They might be using each other's vocabulary, but that's about it. And then today we're looking at mid-segment, and mid-segment goes from middle to middle. And this right here is called the mid-segment. So do know the differentiation of all three of them, so you don't decide on calling midpoint as a mid-segment and so on. And mid-segment has the word mid within, as in it goes from the middle to middle. To me, that's kind of a way to remember it. If you have another way to remember it, create it on your own. And let's notate to say these two are congruent too. So when you're ready, let's go on to the back on example number 2. So on example number 2, what is this segment called? Is it the midpoint? Is it the median? Or is it the mid-segment? Good job. This is a mid-segment. It's a segment created by mid to mid. So given that we know, as long as I know the mid-segment is parallel to the other side, it's going to be half of it. So if it helps for you to put a little dot right here and say this is congruent to this right here, and actually there's already one tick mark, right? Let's do 3 tick marks. So we know the y value has to be how many then? 6. If the whole thing is 12 and I'm dividing them in half, it's also congruent to that mid-segment. And then to find out angle x, I think I'm going to use highlighter for this one. When two lines are parallel, cut by a transversal, any color you want after that, we know x is an obtuse, 65 is an acute. Clearly, they're not equivalent to each other, but they are what to each other? Supplementary. Very good. So we know x has to be how many then? 115. So there's our x, there's our y. So let's go on to example number 3. Josh, go ahead and read example number 3, please.
A, B, and C are midpoints of the sides of triangle XYZ. If BC equals 3M and XY equals 4M plus 10, find M.
Find M. All right, so we know BC is 3M. Let's label it within the figure. And XY as a whole is 4M plus 10. And we know as long as I have my mid-segments, the parallel parts are double the other or half of the other. So in this case, clearly these two segments are not congruent to each other. But I know if I take 2 of these, it's going to be equivalent to this. Or can I take half of this one and equivalent to the smaller piece? It really doesn't matter which one you take. What do you want, half or double? Double. So we have 4M. If you said half, go ahead and use your method and let's compare. And then double the 3M times 2. So I get 4M plus 10 is equal to 6M. And when I subtract 4M on both sides, we get 2M on the other. So how many is our M then?
5.
Josh, did we get the same answer with halving it? Yep. Someone's on their phone and they're just going at it. I wonder who that is. Put them away. All right. On example number 4, Hayden, let's read.
If the perimeter of ABC is 30, what is the perimeter of XYZ? Use
All
the
right.
diagram in example 3.
So we know perimeter of ABC. Is that the smaller one or the bigger one? Okay, so let's write out small. And then perimeter of XYZ is our bigger one. And we know our perimeter is 2-to-1 ratio. So if I gave you that perimeter of smaller one is 30, then the bigger one must be how many?
13.
Bigger one, 60. But you have the same similar, topic or logic, half or double. All right. Is everyone good with that one?
Wait, so it's just twice as much.
Yep. And in case that was a little reminder you needed, the perimeter of the smaller one is half of the bigger one. And that's what we wrote on the after the figure on the front page. Okay? All right. Okay, make sure you study this. Okay, Macy, go ahead and read number 5.
Exactly one of the values of ABC can be determined.
Find it. Okay, exactly one value. So it's either A, B, or C, not all of them. All right? So here's a method that's going to work out every single time. Today we're looking at mid-segments. It goes from middle to middle, correct?
Mhm.
So what we're going to do is find the middle of the triangle by looking at the values. If I have 5 and 5, would you agree this has to be in the middle? So let's write out midpoint as in mid. And then looking at the bottom, if I have 6 to 8, does that make this point the middle?
No.
No. So look at the right side. If I have 7 and 7, does that make this one the middle?
Yes.
Yes. So once you have these 2 points, connect them. And whatever you connect, the variable that is touching is the one that's going to be the one that we can determine. So let's write out B. We can determine B. And then once I have this, I want you to highlight the parallel part. And on the parallel part, you might go, well, 6 and 8 is different. It doesn't matter because the bottom line is when I put this together, it's got to be 14. And when I know my long segment is 14, the shorter parallel has to be what of it? Half of it. And so we know B is going to be 7. All right, let's go on to the next page.
Wait, so for these
Uh-huh.
triangles, how do we know, like, for example 3, how like all of them were like congruent to each other?
Mm-hmm.
How do we know? And like in example 5, they weren't. Like, how do we know? Because they look kind of the same.
Because it says they are the midpoints, so you can go ahead and notate them.
Okay, it's not like a certain kind of triangle.
Yeah.
Okay.
It'll give you a given fact about the feature. Okay? So let's go on to the back. So for this one, we have 3 triangles that are stacked up on top of each other. So let's think about how we should go about solving for x. So when solving for x, let's think about what part is going to be relevant. Do I need this piece to solve for the x?
No.
So let's kind of think about hiding this number. Or not number, the triangle. If I hid this triangle, do I have mid-segment to mid-segment? So I could then say that 10 is going to make this a 5. But that has nothing to do with the x, correct? So instead, I can go ahead and put these 2 together and say 4 plus 4 is 8. Then I have 2 plus 2 is 4. So then I have the mid-segment or the midpoint of these 2 are these 2 points, middle to middle. Could you have redrawn the figure and ignore the top line if you wanted? If that helps. So we know these 2 are the parallel parts from mid-segment to mid-segment. So how many must be my x then? 20. So again, if you wanted to redraw this figure, you can. All right. So let's kind of wrap up all the definitions that we went over this week and see which ones you can remember. All right. So go on to the bottom. These are very important for your quiz and test. All right. For an altitude. Altitude has to go from where to where?
Top to bottom. Or the
Vertex?
to the base.
Not the midpoint. Altitude is something that is
To the perpendicular.
to the opposite side.
Yeah.
So let's look at two scenarios where one of them is going to be in the inside and the other one is going to end up on the outside. So here's my vertex. And if I make this perpendicular to the opposite side, that is my altitude right here. So I'm going to highlight this piece so you know if an altitude is a segment or a point. That's my altitude. Now, does that mean there's only one altitude in one triangle? There's three total, all right? I'm only emphasizing one because when there's too many lines, our brains go, nope, all right? So the second one, let's make this one our vertex. And if I drop this straight down perpendicular to this one, I know I'm not going to have enough segment, so let's make a dotted line to say, here's our imaginary continuous line. And when I drop this straight down, that is my altitude. So depending on the triangle and the position of the vertex you're looking at, the altitude can be on the outside. So imagine a string with a paper clip, and I drop this straight down, it's going to land right here. Or if I had a triangle like the first one, imagine a paper clip, drop it straight down, it's going to be within. All right? So then let's look at angle bisector. On an angle bisector, I want to look at this angle. And I want to pinpoint where the bisector could go. And let's go ahead and connect and notate. This is the angle bisector right here. So I'm going to draw the arrow to say the segment is the angle bisector. Bless you. How many things must be met for perpendicular bisector? Two things. It must be perpendicular and it must go through the midpoint. So two things are happening. So I'm going to start with the midpoint. Here's my midpoint. Does that mean it has to go through the vertex for it to be perpendicular through this?
No.
No, it has to go straight down. And that is our perpendicular bisector. Voila. And the median and mid segment, did we do that already?
Yes.
Go ahead and reiterate that. If you need to look at the front of the page, I'm okay with it, but reiterate that. Because the bottom two is today's lesson. And compare with your neighbor, please. Okay, if you're done with these two, give me a thumbs up because I'm going to give you some hints for your next assessment. All right, let's compare what you have is what I have. Medians from the vertex to the midpoint versus a mid-segment is middle to middle. Is everyone okay with that? If you phrase it in a different format, don't change it, okay? Because if that's the way you want to phrase it, that's the way you might understand it better, okay? So it doesn't mean my phrase is the best. So yesterday I gave you guys a phrase with crunchy something. What was that?
Crunchy peanut butter
Is always good?
Is always best on
There you go. It is cold, so it's perfect, right? So let's do a quick recap. So yesterday I gave you a way to remember them with the actual word that it meant. Today I want to go ahead and fill it in with what it's actually representing. So we have crunchy peanut butter, as in CPB. Crunchy stands for circumcenter, created by perpendicular bisectors. So if you see a fill in the blank tomorrow and you see perpendicular bisector, you select circumcenter. All right, that's the idea. The second line is always best, as in is I, always A, best B. In center is created by 3 angle bisectors. And I know some of you guys are writing this yesterday, which is great, but I'm going to reiterate it. And then we have on A, OA, orthocenter created by 3 altitudes. And then cold morning. How did I like to say morning? Morning. All right. Just to kind of avoid that G, because median starts with M and ends with the N. So it's a good reminder. Yes? All right. Another topic that I did not share with you, I believe on Monday or Tuesday. I forget which day exactly it is. How many of you guys are familiar with PVC and PSI? What is a PVC, by the way?
Isn't that a PVC?
Yeah, it's a pipe. Okay. So I had a student come up to me 2 years ago and go, hey, there's a way to remember to see what is equidistant where. And I was like, share with me. What about PSI? What's a PSI? Pressure of the air, right? Specifically in the tire or in physics. So here's what the student shared with me. And I think this is very valuable. Y'all ready? Here's our PVC. When the point is congruent to the vertex in a triangle, that point is called the circumcenter.
Wait, what?
I'll go back to our notes. Or Macy, do you have your notes from 5.1 or 5.2 specifically? Since mine's in the binder. And I'll talk about this looking at the picture. My cover sheet is a mess. And then our next one is PSI. PSI. When it's congruent to the point to the side, it is the end center. Yeah, give me that one. So write this down first, and then I'll explain it with the picture. Macy, can I write on your notes?
Yeah.
Okay. All right, so we want to see a picture. So eyes on the board. We know from the point to the vertex is congruent no matter what, as long as I have a circumcenter. So when the point to the vertex are congruent, it's called a circumcenter. Okay, I'm going to move on to the end center. On the end center, when the point is congruent to the side, isn't that the side of the triangle? Then it must be the end center. And again, that was just one way of remembering for that specific student, and I think that's pretty clever.